plant watering system in Arduino with mobile app controller. Whenever me and my family go for vacations, I used to get worried about my plants because they need water on regular basis. I gone through several options to solve this problem as plants need water according to the moisture level of soil. So I have made automatic plant watering system using Arduino Uno with mobile controller. In this system, soil moisture sensor senses the moisture level of the soil. If soil will get dry, then sensor senses low moisture level and automatically switches on the water pump to supply water to the plant and also give a notification on my mobile as plant gets sufficient water and enough moisture in soil, after which the water pump will automatically get stopped. About Arduino. Arduino is an open-source electronics platform based on easy-to-use hardware and software. Over the years, Arduino has been the brain of thousands of projects, from everyday objects to complex scientific instruments. A worldwide community of markers has gathered around this open-source platform. Their contributions have added up an incredible amount of accessible knowledge that can be of great help to novices and experts alike. Arduino was born at the L'Oreal Interaction Design Institute as an easy tool for fast prototyping, aimed at students without a background in electronics and programming. Which issue I will focus on: to sense the moisture content of the soil and automatically switch on or off the water pump when power is given, to minimize wastage of water, to reduce human dependency for watering plants at home. Coding for the process. Prototype. Which AI tools will you use to build your prototype? The description of hardware and software components required in the design and implementation are as follow. Hardware descriptions at Mega 328 microcontroller, moisture sensor, 12 volts DC motor, relay module, jump wire, power supply. Software description: Arduino IDE, hardware images. System working design. For the purpose of building this system, one will need to properly connect following. This is an Arduino Uno board. Before using it, the program can be compiled from the computer or laptop. After compiling the program, it is ready to use. The process of making system. Step 1. Firstly, Arduino Uno board, relay module, power supply and moisture sensor are set up on the board. These processes are shown in figure 2, and then relay and Arduino Uno board are connected in all pins. Step 3. Moisture sensor is also connected to the Uno board to sense the water content of the plant. This process is shown in figure. Step 4. In this step, the motor is connected to the relay. This is as follows. Testing. Working. Once the Arduino is supplied with the input power, the moisture sensor is also switched on. The system is designed to sense the moisture content of the soil continuously with the help of a soil moisture sensor. The probes of the moisture sensor acts as a potentiometer where the resistance between the probes vary with respect to the amount of moisture content present in the soil. The resistance varies inversely with the amount of moisture content present in the soil. More moisture content leads to improved conductivity between the probes, hence leading to lower resistance. Less moisture content leads to poor conductivity between the probes, hence leading to higher resistance. Based on this resistance, the sensor module produces an output voltage which determines the moisture level, which can be read at analog output (RO) pin. The knob on the sensor module can be rotated clockwise to increase the sensitivity of the sensor, anti-clockwise to decrease the sensitivity of the moisture sensor depending on the nature of the soil. 17. Based on the output received by the moisture sensor through RO pin, the Arduino which is programmed will turn on the water pump if the moisture content is less and turn off the pump when sufficient amount of water has been pumped. Result. On inserting the moisture sensor probes into the dry soil, the sensor successfully sensed the absence of moisture in the soil and hence the water pump was turned on automatically, hence watering the plant. Once the soil was wet enough, the water pump was automatically turned off as the moisture sensor had sensed the presence of moisture content in the soil. Just the right amount of water will be released and the water will be directed to exactly where it is needed through water pipes, i.e., to the bottom of the stem, so that the roots get the maximum use of water, hence minimizing the wastage of water. Conclusion. By designing and implementing this simple and easy automatic plant watering system, the maintenance of household plants becomes easy for those who travel quite often, very much busy in their work and tend to forget to water their plants. They have to just see to it that the container in which the water pump is placed contains enough water to pump. Further enhancement of this project can also be done in the medical field, where certain medicinal plants require frequent watering of the right amount of water at the right time, which will be very difficult to be watered by human hands.